everyone, welcome back. So we talked about the discovery of cyclic AMP in our last video, and now I just want to make a note about first messengers and the primary messengers and second messengers. So primary messengers are usually the kind of species that will bind to a single receptor group or a species. So bind to a single receptor species. On the other hand, secondary messengers or second messengers, they have a wide variety of functions and they can stimulate lots of things, right? So they stimulate a variety of cell activities. Stimulate variety of cell activities. And they can go on, you know how in one of the initial videos we talked about biochemical pathways. So these secondary messengers can go about doing a lot of things, and primary messenger, like they're obviously very important, but they're limited to a single receptor species. Okay, so that finishes off our topic for the cyclic AMP and second messengers in general. Now what I want to start off with is lipid-derived second messengers. So there are lipids in our cells, we all know that, and lipid, oops, in a second, lipid-derived second messengers. Now, what are lipids? Just a refresher on that. We all know lipids, they have their molecules like wax, fats, oils, and so on. And there's many different kinds of them inside our bodies, phospholipids, sterols, waxes, and stuff like that. And the main functions are energy storage, structural component of the plasma membrane, which should remind you of phospholipids. Structural membrane of plasma membrane. Structural component, I should say, not membrane. Structural component of plasma membrane, and signaling molecules. And we are concerned with this function here, the signaling molecules. And it's mostly so they're referring to lipid derived molecules here, not just lipids, but lipid derived molecules that act as signaling molecules. Now here's a table that is in my notes, and what they show you here is that you have all these different lipids, and they tell you their relative levels and percentages in our cells, okay? And you don't have to worry about this part of the table, but look at how so we have these first three that are present in very, very large quantities. 8.5% is a lot. So those numbers are pretty high. But if you look at these guys here, and you will get to know them shortly, these are the important signaling molecules. Okay? Signaling molecules. And you'll get to know each one of them. This is referred to as PI3P, PI4P, and so on. So their relative levels are pretty low, but they are extremely, extremely important signaling molecules. Okay. Now lipids, cell membrane phospholipids, were originally viewed as structural components that make membranes cohesive and impermeable to aqueous solutes. But we now know that they form precursor of a number of second messengers. Phospholipids are converted into second messengers by a variety of enzymes that are regulated in response to extracellular signals. So all these molecules that you see on the bottom, they're all lipid derived. So you'll have one phosphoinositide or just an inositol ring, and I will explain this in one more time in the next video. But your inositol ring basically has hydroxyls on all your carbons. Now if you substitute any of those hydroxyls with a phosphate, with the phosphate group, yeah, then you get one of these, okay, depending on what position you're looking at. So we'll look at this in the next video, since this one is coming to an end in 16 seconds. So we'll see you guys in the next video.